say k equals 1, and what is the last one? Yeah, from what? Yeah, if you want to use I, it's fine. From I, indeed. Let's check. When I is 1, I get 1, then plus. When I is 2, plus 2. When I is 3, plus 3. When I is 4, plus 4. When I is 40, plus 40. And of course, we can determine this with the graphing calculator very easily, right? Or we can use the formula nn plus 1 over 2, and n is 40, and we can determine it much faster than the calculator can. Okay, we're not asked to do that. Okay, so now, where does this start? You want to stick with I?
Yes.
Okay, I is what? Till what? Careful. 1, 2, 3, 16. From 1 to, yeah. And now we know it has to be a fraction. The last term gives us the hint of what to write. But it has to be I, right? Because it has to go from 1 to 16. It goes from 1 to 16. So it has to be I over, careful, I plus 2. Let's stop for a moment and check this. When I is 1, forget about the last term. When I is 1, do I get 1/3? When I is 2, do I get 2/4? If I don't, this is wrong. Oh, yeah. Yes. When I is 3, do I get 3/5? When I is finally 16, do I get 16 over 16 plus 2? That's it. Okay, here's another. 52. Same page. 1 over 9 plus 2 over 9 squared plus 3 over 9 cubed plus dot 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 plus the last one, n over 9 to the nth power. They want us to write the summation notation. Carefully think. I equals 1. Indeed. It must be a fraction. Yes, indeed, over. Careful. 9 raised to. That's it. That's it. So, yes, we can write that. It's very clear. But so is this. When I is 1, we get 1 over 9. When I is 2, we get 2 over 9 squared. When I is 3, we get 3 over 9 cubed. Dot, dot, dot. When I is finally n, we get n over 9 to the n. This is called the general term. It's denoted by a sub n, n over 9 to the nth, general term. Okay. Any questions? Okay, finally let's talk about sequences. We had all the prep we needed. We know the factorial, we know the summation notation. Now finally we can talk about sequences. A1, comma, A2, A sub 3, A sub 4, dot, dot, dot. A sub n, comma, dot, dot, dot. Normally we only use 3, so don't put 4. 4 dots, not good. By convention, we only use 3. I got carried away. Okay, so this is the first term of the sequence. Of course, the second, third, fourth, and of course, this is again the general term. General term of the sequence. So as you see, this is a list of numbers. It's basically a function. It's a function between 1, 2, 3, 4, n natural numbers. And when n is 1, I have a number. When n is 2, I get another number. When n is 3, I get another number. So it's a function. Okay. Let's suppose we are given the general term. And I'm going to look at a problem. Let's say 5. We're given the general term as being -3 to the nth power. They're asking us to write the first 4 terms of each sequence. So in other words, find A1, find A2, find A3, and find A4. What does this mean? What do I have to do with the general term to find A1? What? I plug in what? What do you think? Compare AN with A1. 1, right? So this will be -3. How do I determine A2? This is exactly what we just did, right? Let's do this again one more time to make sure this is clear. So when I was 1 over 3, I got the first term. So this is A1 because N was 1. How do I get the second term? When I is 2, or N is 2 if you want. 2 over 4. That's how I get A2. How do I get A3? When I is 3. 3 over 5. How do I get AN? N over N plus 2 as the general term. Okay, perfect. So then, can anyone give us A2? The second term of this sequence with a general term. The general term is given to us. Yes, -3 squared, which is 9. Awesome. A3. Very good, but negative. This is an alternated sequence, positive, negative, positive, negative. And then the last one is -3 to the 4th, which is 81. So how will this sequence look like? Like this. -3, comma 9, comma -27, comma 81, comma 3 dots, and comma -3 to the nth power, comma infinite sequence. How is this a function? Well, it is. When n is 1, I got a number. When n is 2, I got a different number. When n is 3, I got a different number. And so on and so forth. That's it. We were only asked to find the first 4 terms given the general term. We're asked to find the first 4 terms. And I said, okay, since we have the first 4 terms, let's see how this sequence looks like. When n is 1, I get this. When n is 2, I get this. And it's a function between natural numbers and these. Okay, here's another example. Number 9. So the general term is given. The same question. We're asked to find the first 4 terms. And then I will also ask you to write the sequence and see how it looks like this one. Can anyone give us A1? That's it. Can anyone give us A2? That's it, which is 2/3. Good. Can anyone give us A3? That's it. And finally, A sub 4. So A divided by 8, which is 1. Very good. So how will this sequence look like? Like this. 2/5, 2/3, 6/7, 1, 3 dots, 2n over n plus 4, and it can continue forever. Yes?
So if we're asked to write the sequence, we're writing
That's the sequence. A1, comma, yeah. By definition, the sequence is A1, comma, A2, comma, A3, comma, A4, dot, 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 comma, AN, blah, blah, blah. If it's an infinite sequence.
But if we're asked to find a solution, then
They're not solution, they're just the first 4 terms of the sequence. We were asked to find the first term, the second term, the third term, and the 4th term, so you can come up with a sequence. Okay, should we look at another example? Very good. Okay, let's look at 12. So A sub n equals -1 raised to n plus 1 over 2 raised to n and plus 1. This looks ugly. It's not. It's just to impress. Same question. We want to determine A1, and then A2, and then A3, and then A4. When n is 1, we get 1 over. Excellent. When n is 2, again, this is going to be an alternated sequence. Positive, negative, positive, negative, positive, negative. Yes, the numerator is -1 and the denominator is, very good. So this is -1/5. Excellent. Good. A3. It will be 1 over, is it 2 to the third, which is 8. 8 plus 1 is? Good. Awesome. And the last one that we need, -1 over 16 plus 1, 17. So then the sequence looks like 1/3, -1/5, 1/9, -1 over 17, dot, 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 -1 raised to n plus 1 over 2 to the n plus 1. Really the last new thing right now. In previous examples, we were given the general term. Sometimes that is not possible to be determined without the help of the previous term. That is called a recursive formula. So I don't have a sub n. Well, I do, but not directly. So let's look at problem 17. Here's what problem 17 says. A1 is 4. What does this mean? The first term of the sequence is 4. And then they say A sub n, which is the general term, equals twice times A sub n minus 1 plus 3, of course, for n greater than or equal to 2, because I already have A1. So what does this say? It says I cannot determine the second term if I don't have the first. So if this is 2, then this is 2 minus 1, the previous one. If you ask me in the previous cases, if you say here, find number 1,000, A 1,000, no problem, I'll plug it in, I'll give you the answer. But here I can't. If you say find A 1,000, I say no, I'm sorry, I can't. I have to find A1, I have to find A2, I have to find A3, I have to find A4, I have to find A999, and then I'll tell you A 1,000. Because it's given us a recursive formula. Each term depends on the previous one. So term 99 depends on 98. If I don't have 98, I cannot determine 99. So luckily, we're only asked to define the first 4 terms. I already have A1. Can anyone, without calculating anything, just for everyone to see, tell us how to calculate A2? So it's 2 multiplied by A1, very good, and plus 3. 8 plus 3 is 11. Now I'm able to find A3, because otherwise without A2, I will not be able to find A3. So what does A3 equal to? 2 times times the previous one, which is 11, and plus 3. So 22 plus 3 is 25. What about A4? A4 equals 2 times, exactly, plus 3. 50 plus 3, 53. But I can't tell you what A 1,000 is, because I have to determine the previous 999. Okay, so let's look at another example. Let's say 15. we're given a1 equals 3, a sub n equals 4, a sub n minus 1 for, of course, from 2 and above. Same question. We want to determine the first 4 terms. A1 is clear. What about A2? Yes, 4 times 3 equals 12. What about A3? 4 times 12, 48. Excellent. What about A4? 4 times 48. So that's 2 and 3, right? 192, is it? This is it. There is nothing else I can teach you from this class. So we know what we learned today is how to manipulate the factorial, how to work with the summation notation, plug in calculator if I need to, and how to determine terms of a sequence. Okay, so if you have your handout here, I like to start from the very end because I think that these will be, hopefully, soon, the easiest things you can determine or think about. We have 8 minutes, so let's use them efficiently. Okay, so this is the last page, I believe. Maybe not. Is there something on the back? No, there isn't. So this is the last page. So let's start with this. Number 27. Express the sum using summation notation. 1 plus 3 plus 5 plus dot dot dot, as you see exactly 3, plus 2n minus 1. So we want to use I. I from what? Good. Till what? Excellent. Good. From what? And I have to use I. Let's check. When I is 1, do I get 1? When I is 2, do I get 3? When I is 3, do I get 5? Yes. When I is n, do I get 2n minus 1? Nothing, really. Okay. We're going to finish this page, I think. Yeah, we have 6 minutes. So this should take you on a test like 2 minutes and a half. Okay. So we are given a1, which is 4, and here's the formula. 3 times the previous one plus 3. I have a1, 4. A2. 3 times the previous one plus 3. 15 indeed. A3. 3 times the previous one, 45 plus 3, 8. Excellent. A4. 3 times the previous one plus 3. That's it. Done. Okay, let's evaluate the factorial expression. Which one, top or bottom, is bigger? But yes, now we know that this is very easy, but it took me an hour to explain because there was a lot to say, and the first few examples we didn't know where they're coming from, right? So that's why, sorry, sometimes it takes me longer to explain. So which one is bigger? Right. So how will you simplify the top? It will be n plus 1 times n factorial. So the answer is, that's it. So initially, last time when I handed out this, you looked at them and they were looking like gibberish, right? Nobody knew what they meant, but now okay, what about here? So when a is 1, 1 plus 1, so the top is 1, so 3 minus 1, so I have 1/2. A2. Yes, negative 1 over 3 squared is 9. 9 minus 1 is 8. A3. The top is 1. 3 cubed is 27 minus 1 is 26. And the last one? Yes, indeed, negative at the top. And 3 to the 4th is 81 minus 1 is 80. Last one here. There is nothing we can do. We have to use a calculator. On this one, there is no choice. So 40 factorial, I don't think the calculator can do 40 factorial. I really don't think. But because it's divided by 450, it can. So I'm gonna try. I have not tried it. Oh, it's huge. It's 10 to the 47th power. So I should just put everything at once. This is the correct way. And divide by 450. It's still huge. It's 1.8 times 10 to the 45th power. I was surprised that it did 40 factorial. So the answer is 1.81 times 10 to the 45th power. So basically it took us, what, 3 minutes to do one page. And that was it. There is nothing else from this section. So we did this 23 last time, and then we'll work our way back step by step on that.